In this section, we're going to look at solutions of quadratic equations, namely the discriminant, and there's a lot to say about the discriminant. But you may recall that the expression b squared minus 4ac is the part of the quadratic formula that is inside the radical. In the quadratic formula, this b squared minus 4ac is called the discriminant. It determines what types of numbers the solution of a quadratic equation might have. So if you had values of the discriminant equal to 0, this will give you one solution that is a rational number. If you have positive values inside your discriminant, b squared minus 4ac is greater than 0, you either have a perfect square or not a perfect square. If you have a perfect square, your solutions are rational. And if you do not have a perfect square, your solutions are irrational conjugates. Finally, if you have a negative discriminant, where b squared minus 4ac is less than 0, you'll have two different imaginary number solutions. They're called complex conjugates. So let's practice this, and let's look at the discriminant to determine what we can imply about our solutions. For each equation, determine what type of number the solutions are and how many solutions exist. So remember, we're looking at the discriminant to determine what we can expect for solutions. So b squared minus 4ac for this first example would be a equals 1, b equals -6, and c equals 9. So b squared will be 36 minus 4 times 1 times 9. So we'll have 36 minus 36, which equals 0. If we have 0, that means we'll have one solution that is a rational number. Let's look at the next example. X squared minus 5x plus 3, a equals 1, b equals -5, and c equals 3, where we have b squared minus 4ac, and we need to determine what type of properties that this discriminant has. Substituting -5 in for b and squaring it, we get 25 minus 4 times 1 times 3. This gives me 25 minus 12. If we look at 25 minus 12, that gives us 13. Now if we have 13, we can go back up to our table of information about the discriminant. We know that the discriminant would be greater than 0, but it is not a perfect square. 13 is a prime number. So our solutions are irrational conjugates. So let's go back down here. We would say 13 is greater than 0. We have two solutions that are irrational conjugates. Now let's try C. We have 4x squared plus 8x minus 5 equals 0. A equals 4, b equals 8, and c equals -5. Using our discriminant b squared minus 4ac, we can see that b squared would be 64 minus 4 times 4 times -5. This gives us 64 plus 80. If we add 64 and 80, we're clearly going to get a positive number, so this number is greater than 0. Now we need to determine if it is a perfect square. So if I add 64 and 80 together, I get 144 is greater than 0. Since this 144 I know is 12 squared, it is a perfect square trinomial. So we can go back up to our table and notice that we have a perfect square this time. And so we'll have rational solutions, but there will be two solutions. Two rational solutions. Now let's look at the last one here. We have m squared minus 2m plus 4 equals 0. This means a equals 1, b equals negative 2, and c equals 4. We can use the discriminant b squared minus 4ac and substitute the values in. Negative 2 squared is 4, minus 4 times 1 times 4. This will give me 4 minus 16. We can see that this combined or simplified will be negative 12. And so if I notice that it's negative, I know that I'll have complex conjugates. So I'll have two solutions that are complex conjugates.